Archiving started.
Hi everybody, this is Kara, and we're back for another walkthrough of a problem. This one is from session 9, homework problem number 18. Again, I just did number 13, so if you watch that one, you're going to see the same shaky cam work. My little stand that I use for my camera is broken tonight, so I'm having to hand hold this. I hope it's not too nauseating for you to watch. So this was from session 9, problem number 18. And it's about drug concentration in a patient's bloodstream a certain number of hours after an injection. So we have the formula for that, and it was given to us in the problem, that the concentration, C of T, is going to equal T over 7T squared plus 2. And so the first thing it wants us to do is to find the horizontal asymptotes and then also to see what happens to C of T as T approaches infinity. And I've already written the answers out here just so I had them in front of me while I was working this, but let's walk through how we would do that. So first of all, we need to enter the equation into our calculator. Let me get them so I can see them both at the same time. So I'm just on my y equals screen. If you watched the last video, I cleared out everything in my y equals screen just using the clear button to make sure that I didn't have anything in there. You might also want to, on your window, go ahead and reset it to a standard window before you start. It's just kind of good practice to do that. You can always reset it later. It's no big deal. But I just tend to do that after I have graphed anything. I like to go back to a nice clean slate. So I'm going to go here to Y1, and I'm going to enter in. And again, I like a nice healthy amount of parentheses, so I like to put the numerator in parentheses. So it's going to be X, that's our T, divided by, and then parentheses, 7x squared plus 2, parentheses. Remember, if you've not watched the other video, the x key is the one that has the little, let me try not to use my finger here, the x and the t and the theta and the n, and then our squared key is just down here, and I just have to hit it, and that actually gets the squared right on the screen for me. Okay, and this is all on the T83 plus. So I'm going to go ahead and I'm going to graph that, and it's going to look like absolutely nothing happened. Yeah. If you're not sure if it's done yet, remember to look up here in the right corner, and that will show you whether or not the graph is actually finished running. If you don't see any little, I call them little worms running up and down the screen anymore, then the graph is actually finished. Okay. So what happens when you graph it? Nothing happens. Well, there's a great trick that I love, and it's called Zoom Fit. So you're going to hit your zoom key and arrow down. I think it's number 9. Nope, it's 0. You can either hit the 0 or hit enter. So I'm going to hit 0, and those little worms are going to march up and down the screen again. But you notice now I'm getting a graph. Now let's just take a look at this for a second, because just to see why in the world we didn't see it before, let's take a look at our window settings. Look at what your Y min is here on your window. That Y min, so on your horizontal axis, your X and Y axis, pop this off here. So your Y axis, this value, the very bottommost value here, is negative 0.13, and the very topmost value is 0.13. So notice that I've got a really, really, really tiny graph, okay? So let's take a look at our graph again. Okay, sure, let's see that. All right, so the question asks us to find the horizontal asymptote of C of T. Remember, horizontal asymptote, we want to know what happens as X, or in this case T, approaches infinity. And what it looks like the graph does is it looks like it shoots up right there at the beginning, so that makes sense. I'm giving somebody an injection. So as soon as I give them that injection, they're going to have lots and lots of that drug in their bloodstream. And then it's very slowly going to metabolize or dilute out or whatever the body's chemical reaction is for it that it does, and it's going to actually end up disappearing out of their bloodstream. So it ends up looking like it approaches 0, okay? So we're going to have a horizontal asymptote at C equals 0, okay? And so it asks you basically the same question again. What happens to C of t as t approaches infinity? What value does C of t approach? And it approaches 0. Now, what they're trying to get you to see here, they could have been a little more obvious in the way they ask it. They're trying to get you to understand that. Remember, C of t is the concentration of that drug in your drug stream, in your bloodstream. So as the time increases, time goes to positive infinity, you're going to have less and less and less and less and less of that drug in your bloodstream. Now, this is a drug that, according to the mathematical model, according to this, you're never going to get rid of. Now, again, this is a mathematical model, so remember, in the real world, eventually, there probably wouldn't be any traces of that drug in the bloodstream. I don't know exactly what this drug is and whether that's completely true or not, but most likely you wouldn't have any more in your bloodstream, okay? So now, for part B, now they tell us to select the graph, and this is another one of those multiple choice ones, that has a very certain set of limits or windows. So I'm actually just going to type those numbers that they gave you there right into my window screen. And there's no way that I can do this so that you can see. Actually, let's try this way. I go out to there. There we go. That'll work. Okay, so if I go to my window screen, and I enter in my x values of 0 and 5. They're not very nice to you. They don't give you these in a very convenient form. And I'm going to use an x scale of 0.5. And then my y min is going to be 0. And my max is going to be 0.27. And my y scale is going to be by 0.03. So teeny, teeny, tiny little graph. And then I'm going to take a look at the graph. There we go. Okay, so it's got a nice big hump right there at the beginning, and then it kind of wanders off. So then we've got here on the multiple choice question, we've got 4 graphs that it could look like. And you kind of just have to inspect it. Now, really and truly, I would have a hard time telling the difference between B and C on here. So you've really got to inspect that really, really well. On my graph here on the calculator, I'm not sure if I'm going to be able to get in close enough, and this is going to be clear enough for you to see this, but I would count the tick marks 1, 2, 3, 4, so that hump is between the 4th and 5th tick mark. And then going across, the hump is between the 1st and the 2nd tick mark. And that's actually kind of what differentiates B and C from one another, if anything does. But if anybody got this counted wrong because you picked B when it should be C, drop me an email and I'll take a look at that, because those are really, really, really close together. It looks like A and D are the same too. That could have happened when I printed it too, and it may have just inserted funky graphs in there, but you just never know. Okay? And so then the last part of this, they want us to find out at what concentration or at what time is the concentration the highest. And the calculator is going to do the heavy lifting for us again here. Let me get it so we can see it. So they want to know, essentially, what does T equal right here at the top of the hump? Okay? Okay. So, again, we've got another one of those nice calc functions for a maximum value. So I'm going to do my second calc. And I'm going to pick a maximum, which is number 4 on my calculator. You can arrow down to it, or just hit the number 4. And this is one of those ones where you have to hit the left bound. So you want to move the little blinky thing until it is somewhere to the left of the maximum value. Blinky thing is our technical word for the evening. Move over there. There we go. As long as I'm to the left side of it, that's all that matters. I hit enter. It's going to ask me for the right bound, so I move over until I'm on the right side of the maximum or that hump. Hit enter, and then I want to try to get my little blinky thing right on top of that max value. It's going to process for just a second, and then it's going to spit out the maximum value to me, the maximum value that happens at x equals 0.53. Okay? So that should walk you through everything you need to know for numbers 13 and 18 if you watch both videos. Have a great night, guys. Bye-bye.